This lesson will help you determine whether two equations will be graphs of parallel or perpendicular lines. This lesson discusses the relationship between the slopes of parallel and perpendicular lines. So for two lines to be parallel, and remember parallel means they will never intersect. So for example, like that. So parallel lines, if they went on and on, they would never intersect. In order for two lines to be parallel, their slopes must be the same. If their slopes are the same, they're going to go in the same direction and not intersect. Two lines are perpendicular if the slopes, it's called negative reciprocals. And just as a reminder, perpendicular means that when the lines intersect, you will have a right angle. So remember, a right angle means that it's in a box. It will make a 90-degree angle. If they are not the same or they're not reciprocals, then they're just intersecting lines like this. Just normal intersecting lines. Or like this. So you could either have intersecting lines, parallel lines, or perpendicular when you're graphing two lines on the same graph. So perpendicular, they have to have negative reciprocals. What that means is one of them is negative and one of the slopes is positive. That's one condition. Then they have to be reciprocals. So like 4/5, if I flip-flop the 4 and the 5 in the numerator and the denominator, I have 5/4. 3 and negative 1/3. Notice one of them is positive and one of them is negative. You have to have that. And then if you take 3 over 1 is the same thing as 3, and switch them, you get 1/3. So in order for two lines to be perpendicular, you have to have that relationship. So we're going to do some examples to determine whether the lines are parallel, perpendicular, or neither. Okay. So here we're given two equations and we have to determine whether they're parallel, perpendicular, or they're neither. They just intersect, but they don't have anything special about them. So if we look here, the number in front of x, remember, is the slope. So the number in front of x here, they're the same. They're both 2/3. That means that the lines, when graphed, are parallel. Now notice I have graphed these two equations, and you will see that the slope for both of them is 2/3, because if I pick 2 points, I have to rise 2 and run 1, 2, 3. So the slope on both of these, and notice they're both going up, so positive, and if I pick 2 points here, so I pick this point and this point, notice I'm rising 2, and then I run 3. So they both have a slope of 2/3, and that is why they do not intersect. So they are parallel because they have the same slope. They have to be the same sign, exact same slope. Okay, now if we take a look at this example here, you will notice the number in front of x here is positive 1/2. So it is positive. The slope here is negative. So they're definitely not the same. 1/2 is not the same as -2, so they're not parallel. And one of them is positive and one of them is negative. So to be perpendicular, one is positive, one is negative. So far so good. And they are reciprocals. So if I take 1/2 and I switch the numerator and the denominator, we get 2/1, which is 2. So it meets the requirements of being perpendicular. So notice the slope here, if I pick 2 points, the slope, if I rise 2, and I go to the right 1. So this line has the slope of 2. So that means it's going, or has a slope of, from left to right, it's going down. So this has a slope of -2. This one, in order for 2 lines to cross, one of them has to be going down and one of them has to be going up. To make right angles, you have to have one going down and one going up. So the slope here, if I pick 2 points, I have to rise 1 and run 2. So as you can see, this is a right angle. They are perpendicular. If I put my piece of paper right there, makes a right angle. And the reason why, again, is one of them is positive, one is negative, and they are reciprocals. So if we take a look at the next example, if we look at the slope, the number in front of x, this one is 3, and this one is -3. They are not the same, so they're not parallel. One is positive, one is negative, so far so good, and they are reciprocals. They are not reciprocals. To write 3 as a fraction, it's 3 over 1. If I flip-flop them, it's 1/3. That is not -1/3. So these ones would be neither. It is not parallel and it is not perpendicular. If we take a look at the next example, notice this one is -2/3 and this slope is 3. So they're not the same, so they're not parallel. One is positive, one is negative, and they are reciprocals. If I take 2/3 and I exchange or switch over the numerator and the denominator, it would be 3/2. That is not 3/2. So this one would also be neither one of them. In other words, you're going to have lines that maybe look like that. They don't make right angles, or maybe they look like this. You don't have right angles. Okay, got 2 more examples here. So if we look here, the number in front of x is 3. The number in front of x is 3. So they have the same slope. So these equations, if we were to graph them, would be parallel lines. In other words, they both will not intersect. Okay, last example. So the slope here, the number in front of x is 1/2. Here, though, we have a problem. The y is not by itself. Remember, we can only identify the slope when the y is by itself. So we're going to have to get the equation and slope-intercept form. So that means I need to get the y by itself. I'm going to subtract 8. And then divide by 2. So we get y equals a -4 divided by 2 is -2. A -8 divided by 2 is -4. So now we have this equation and this equation. So this slope is 1/2, and the slope here, now that the y is by itself, the slope is -2. So they're not the same, so they're not parallel. One is positive, one is negative, and are they reciprocals? So if I take 1/2 and I switch the numerator and the denominator, you get 2. One is positive, one's negative, they're reciprocals. So these 2 equations, if we were to graph, we would have right angles. They are perpendicular.